Hello everyone, let's get started with yet another new episode of Force and Pressure. So in the previous episode we have already discussed about magnetic force, this electrostatic force, gravitational force and all. So today's topic we will be focusing only on pressure, and we will also study about atmospheric pressure and the pressure what is exerted on the liquids as well as gases. So without any further delay, let's get started, and please don't skip the lesson in between because it will be very important throughout the episode. So let's get started. So today's topic of discussion is pressure. So is there any relation between pressure and force? So let us find out that. So if you are trying to push a nail into a wooden plank by its head, did you succeed? So which one is the head? This one is the head of the nail. So if you are just reversing the nail and you are trying to push it with its head in the wooden plank, will you succeed? Now try to now push the nail by the pointed end. Now if you are taking the pointed end and you are not trying to push it, I think you will succeed then. So why it is happening? Could you do the same in this? Now next one is try cutting vegetables with a blunt knife and then with a sharp knife. So this you are not going to experiment on your own. You are going to take support from your parents and you are trying to cut vegetables first with a blunt knife and then with a sharp knife. So which one is easier? Do you get the feeling that area over which the force is applied, for example, the pointed end of the nail plays a role in making these tasks easier? Is it clear? So if the edge is sharp, if the nail point is pointed, it will be easier for exerting the force on that, and it will be easier to do the work. So it makes the role much easier, tasks much easier. So the force acting on a unit area of a surface is called pressure. Okay, so what is pressure? How to define pressure? Pressure is force per unit area on which it acts, right? So at this stage, only those forces which act perpendicular to the surface on which the pressure is to be computed. So if this is the wooden plank, on that if you are trying to insert a pointed nail, so it is acting perpendicularly, right, on which the pressure is perpendicular. So it is to be computed, right? So here she is telling that I now understand why porters place a round piece of cloth on their heads. So you have seen when you move to railway stations, when we are going to from one place to another, you see that the porters, they use a round piece of cloth on their heads when they have to carry heavy loads. So by doing this, they increase the area of contact. So they are increasing the area of contact of this load on their head. So the pressure on their head is reduced. So when they are increasing the area of contact of this load, so what is happening? The pressure on their head is reduced and they find easier to carry the load. So the pressure is reduced. So pressure is reduced and so they are finding it easier to carry a load. So this is very important. If you are getting a question why a porter is placing a round piece of cloth on their heads while they are carrying heavy loads, so you can write this answer. By doing this, they increase the area of contact, and which in turn reduces the pressure on their head and makes the work easier. Okay. Now note that the area is in the denominator. So what is that? So pressure is equal to force per unit area. So area is in the denominator in the above expression. So the smaller the area, the larger pressure on the surface for the same force. So smaller the area, the larger pressure will be there for the same force. If the same force is applied, the pressure will be larger on the surface. Okay. Now, what we will see now, the area of the pointed end of the nail is much smaller than that of its head. Okay, so this is the nail. This is the pointed end. So the area of this part is much smaller than that of the head. So what has happened? Therefore, it produces a pressure sufficient to push the pointed end into the wooden plank. So when you are applying pressure on this part, it is not sufficient enough to push it into the wooden plank. Whereas when you are applying pressure on this part is getting adequate or sufficient pressure to enter into the wooden plank. So is it clear to all of you? I'm trying to making it very clear. So lesser the surface area, greater the force or sufficient force will be there if the same force is applied also. Whereas if you are applying the same force while pressing this blunt part into the wooden plank, you won't be able to insert that. Okay, so can you now explain why shoulder bags provided with broad straps and not thin strap, and why tools meant for cutting and piercing are always having sharp edges? So this in the next slide we will discuss. So till then you just think why we are having school bags with broad and not narrow straps, and why tools meant for cutting and piercing have sharp edges. So let us move on to this discussion part. So just now we were discussing a question that why school bags are provided with broader straps and not thinner ones, and why sharp knives are easier to cut the vegetables with the sharp knives than the blunt knives, right? So what is the reason behind that? So let us find out that school bags are always provided with broad straps because the surface area in contact with the shoulders reduce the pressure on the shoulders. Now, if thin straps would be used, the surface area in contact with the shoulders would decrease, and which will rather increase the pressure on the shoulders. So, if the surface area of contact is decreasing, it will lead to the increase in pressure on the shoulders. So to reduce the pressure, always the surface area has to be more. The surface area has to be increased. So what is pressure? We have discussed that pressure is the force divided by area. So more the pressure is created by reducing the area on the force and on which the force is concentrated, right? So if you are reducing the surface area, the force will be concentrated. Okay, so in that case, the iron nail, which is very helpful as it pushes the nail into the wall quickly. This is why the sharp nail is being used rather than a blunt nail, because it can be pushed into the wall quickly by applying the same force when it is applied to much easier than the force which is applied for a blunt object. Okay, so on the wall rather than a blunt nail is better. Now as this reduces the area of contact, this idea is also same behind the sharpening of knives. So this is same behind the sharp knives. That is, sharp knives, when they are cutting any vegetables, they are actually coming in contact with a very small surface area. Thus the pressure what is being applied is more, and it is actually easier to take on the work, or it is easier to process the work which is being done. Okay, so this is the reason behind using a sharp nail to fix in the wall, as well as using sharp knives for cutting vegetables. And this is why the school bags are always having broader straps than the which are not having thin straps, right? So let us move on to the next part. So this question is already been discussed now, why shoulder bags are provided with broad straps. So now we will move on to the pressure exerted by liquids and gases. So let us concentrate in this activity 8.8 as per your NCERT book. So take a transparent glass tube. So how does it look like? So it will look like this. It is a transparent tube, okay? So take a transparent tube. The length of the tube should be 25 centimeter and its diameter should be 5 to 7.5. So its diameter is 5 to 7.5 centimeter. Now also take a thin sheet of good quality rubber, say a rubber balloon. So you are taking a balloon and you are stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle. So you are holding the pipe in the middle. In this way, you are positioning the rubber tube or the rubber sheet at the end, keeping it in a vertical position. Ask one of your friends to pour some water in the pipe. Does the rubber sheet bulge out? Note also the height of the water column in the pipe. Okay. Now pour some more water Observe again the bulge in the rubber sheet and the height of the water column in the pipe. Okay, so you are pouring some water. What you are observing, you are pouring some water. So this process, you are doing it for a few more times. Can you see any relation between the amount of bulge in the rubber sheet and the height of water column in the pipe? So what you are seeing? You are seeing that the more water you are putting in here, the rubber sheet is bulging out more. So the pressure is exerted by the water at the bottom of the container, which depends on the height of the column. So lesser the height, lesser the force of water, more the height, more the bulging out. So more the pressure is applied on the rubber balloon. So it is clear that water is having pressure, that is liquids are having pressure, exerting pressure, so that this is happening. So this rubber sheet is being swelling up, okay, whenever you are pouring more and more water. So let us move on to this activity 8.9. So when we are moving to this activity 8.9, what we are doing, we are taking a plastic bottle. You can take a discarded bottle of a soft drink, fix a cylindrical glass tube a few centimeters long near its bottom as shown in figure 8.15. So let us see what is happening there. So this is the plastic discarded soft drink bottle. You have fixed a pipe at the end of this, at the lower end of this tube. Okay, so how you are putting it, we will tell you that. You can do so by slightly heating that part and inserting the glass tube quickly. Okay, if you are inserting the glass tube while heating, it will get fixed in that part of the rubber, that plastic bottle. Okay, when you heat the plastic, it will get melted. So in that molten state, you are going to insert the glass tube. Okay, so it is near the bottom of the bottle. Make sure that water does not leak from the joint. So if there is any leakage, you try to seal that that part with molten wax. Now cover the mouth of the glass tube with a thin rubber sheet as you did in activity 8.8. So now what you are doing, now fill in the bottle half with water. What do you observe? Why does the rubber sheet fixed to the glass tube bulge this time? So you are filling this bottle with water. You have fixed a rubber, rubber which you have used in the previous one, like a rubber balloon. You are putting something. So why it is bulging? If you pour more water in the bottle, is there any change in the bulge? You will see it will bulge more. So a liquid exerts pressure on the walls of the container. So this pipe is fixed in the wall, and so liquid is exerting pressure on the walls of this container. So note that the rubber sheet has been fixed on the side of the container and not at the bottom. Okay. So does the bulging of the rubber sheet in this case indicate that water exerts pressure on the sides of the container? So let us investigate that. So the bulging of the rubber tube is indicating that it is exerting pressure on the sides of the container, but we need to prove it further, right? So for that we need to do more activities. So we are moving to activity 8.10. Okay. So you may have a question in your mind that why we are doing so many activities. We could have done one experiment or activity and we could have proved that. So why? We need to be very much sure that whether water or liquid exerts pressure on the side of the container or not. So take an empty plastic bottle again, or a cylindrical container. You can take a used tin or a used plastic bottle, drill 4 holes around a near the just bottom of the bottle. Okay. So make sure that the holes are at the same height from the bottle. Now fill the bottle with water. What do you observe? Do the different streams of water coming out of the holes fall at the same distance from the bottle? What does this indicate? So what you are doing this experiment, you are making holes here, you are pouring water. So does the water coming out, they are coming at the same distance? Okay, so liquids exert equal pressure at the same depth. That means all the liquid coming out from these holes are having a equal distance. Okay. Can you now say that liquids exert pressure on the walls of the container? Yes, they do. They are exerting pressure. You have seen so many experiments to prove that. So do gases also exert? Do they also exert pressure on the walls of their containers? Let us find out that again. So there, with another thing, which it is a daily experience, I have seen fountains of water coming out from leaking joints or holes in pipes. So whenever a pipe is the pipe which is taking water, which is carrying water, that is a water supply pipe, when it is having holes, you can see the pipe water is leaking forcefully. So it is not due to the pressure exerted by the water on the walls of the pipe. Yes, it is due to that only. So this is due to the walls, in the walls of the pipe, the water is exerting pressure. So when you inflate a balloon, why do you close its mouth? What happens when you open the mouth of an inflated balloon? Suppose you have a balloon which has holes, would you be able to inflate it? So many questions are there. So till now we have completed our questions, our queries on water or liquid. So now we are having the same questions with the air. So how the air is acting to this pressure. So that is why, so how we can inflate can we inflate a balloon which is having holes? If not, why? Can you say that air exerts pressure in all directions? So do you recall what happens to the air in the bicycle tube when it has a puncture? Do these observations suggest that air exerts pressure on the inner walls of the inflated balloon or a tube? So we find that these gases too exert a pressure on the walls of their container. Okay, so gases are also exerting pressure on the walls of their container. So now we will move on to what is atmospheric pressure and so on. So now we are here with the atmospheric pressure. So what is atmospheric pressure? You all know that there is air all around us. This envelope of air is known as atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. So this all we have studied in previous classes, that we have a layer of air around us which is extending several kilometers, which is divided into several layers: stratosphere, ozonosphere. Okay, we have studied about the layers, and the pressure exerted by this air is known as atmospheric pressure. So the pressure which the atmosphere is applying on us is the atmospheric pressure. So we know that pressure is the force per unit area. Just now we have studied in the previous part of this video. So if we imagine a unit area and a very long cylinder standing on it filled with air, then the force of gravity on the air in this cylinder is the atmospheric pressure. Okay, so how they are doing this experiment? So this is the full cylinder which is filled with air, and this is the unit area. So atmospheric air is the force of gravity on the air in the column of unit area. So in the column of unit area, what force of gravity on air is applied in this column is the atmospheric pressure. So the force of gravity on this column, what is applied per unit area, is the atmospheric pressure. Is it clear? Okay, so now let us do an activity. So how large or small is the atmospheric pressure? Let us get an idea about its magnitude, right? So take a good quality of rubber sucker. So this is a rubber sucker. You all know that it looks like a small rubber cup. Press it hard on a smooth plain surface. Does it stick to the surface? Now try to pull it off from the surface. Can you do it? So air sucker, you are pressing it on the surface. If you try to pull it, it will be very difficult to pull it if it is a good kind of rubber sucker. When you press the sucker, most of the air between the cups and the surface area escapes out, and the sucker sticks to the surface because of the pressure of the atmosphere. It is acting on this sucker, right? The air is being pulled away. It is fixed to the base or fixed to the table. And to pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. So if you are pulling it lightly, it will not come out of the surface. If you are applying enough force, which is increasing or overcoming the applied atmospheric force, then only you will be able to pull out the sucker. Okay, so this activity might give you an idea about the magnitude of atmospheric pressure. So how powerful the atmospheric pressure is, you can get an idea of that. So in fact, it would not be possible for any human beings to pull the sucker off the surface if there were no air in all between the sucker and the surface. So if there is no air left between the sucker and the surface, then it won't be easy to pull the sucker. So does it give you an idea how large this atmospheric pressure is? I think you got it. Okay. So if the area of my head were 15 centimeter into 15 centimeter, so how much force it will exert on head? So let us do some regarding this, what they are telling. So if your head is having an area of 15 into 15, so the force due to air in a column of the height of the atmosphere, and the area is 15 into 15 centimeters, so it is nearly equal to the force of gravity on an object of mass 225 kg, that is 2250 Newton. Okay, so the reason behind that is, so the reason for that we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the atmospheric pressure. Okay, so that is, pressure inside our body is also this much, and this is balancing the pressure from outside. Is it clear? So it is balancing the pressure from outside, and this is the reason why we are not crushed under this pressure. So you can see this is the atmospheric pressure. The pressure of the atmosphere on your head will be 2250 Newton or 225 kg, though we are not crushed because our body is having equal pressure which is inside our body, which is balancing this kind of pressure. Okay. So now we have come almost at the end of this lesson. So today we will move on to this part, that is, did you know that is Otto Von Guericke, a German scientist of 17th century, invented a pump to extract out of a vessel. Okay, so with the help of this pump, he demonstrated dramatically the force of air pressure. So what he did, he joined two hollow metallic hemispheres of 51 centimeter diameter. So he has just joined these are two hollow metallic hemispheres of 51 centimeter diameter each, and pumped air out of them. Then he employed 8 horses on each hemisphere to pull them apart. Okay, so a great force of air pressure, that is the hemisphere, could not be pulled also. So in each sphere you can see horses are pulling this, but they are unable to pull it apart. So 8 horses each side have been used, so they are unable to pull it apart. Okay, so the great force of air pressure and the hemisphere could not pull it apart. So this is all we have studied in this lesson in 4 different parts. Please do go through it. So what we have studied about atmospheric pressure, contact force, electrostatic force, what is friction, gravitational force, gravity, magnetic force, muscular force, non-contact force, pressure, pull, push, and everything. Including this, we have also studied about atmospheric pressure here. So this is all about your force and pressure. So please do subscribe to my channel, because your next episode is going to come in a very short time. So stay tuned, update with all the lessons which I am posting. If you're having any queries, any doubts, please do write to me in the comment box. So stay tuned, subscribe to my channel, share it with your friends and all. Thank you. Thanks a lot for watching my video.